All right, so today's lesson is going to be focused on how to solve quadratic equations or degree 2 polynomial functions by completing the square, and this is part 2 of that lesson. So today we're going to do some more challenging examples and just try to take this to the next level. So remember, when I talk about solving these equations, what is it that I'm really asking you to solve for? I'm asking you to find the x-intercepts. And what else can we call x-intercepts? So x-intercepts actually have a couple names, and we already know one of them. My screen doesn't want to stay put today. The x-intercepts can also be referred to as zeros, and we can also call them roots. So you might see x-intercepts referred to as zeros. You might also see them referred to as roots. So anytime I'm talking about x-intercept, zeros, or roots, I'm really talking about the same thing. I'm talking about the x values of these points right here. Where does my parabola cross the x-axis? These are the zeros of the function. These are my x-intercepts, and they can also be called the roots. And we'll talk about why they can be called the roots in just a second when we solve this problem by completing the square. So let's go ahead and follow our steps. I put our steps here for us just as a reminder. So step 1 is we need to make sure that the equation is equal to 0. So right now, x squared plus 14x minus 51 equals y. It's equal to y. We need this to be equal to 0. So we're going to plug in 0 for y. And why do we do that? Because at these points right here, if I labeled these points with their values, so if I wrote these as points, this would be 6, 0. And then this point would be 3, 0. What are the y values of both of these x-intercepts? 0. So anytime you have an x-intercept, y is equal to 0. So anytime that we're finding the zeros, we're finding the roots, we're finding the x-intercepts, y is equal to 0 at all of those points. So that's why we're plugging in 0 for y here. All right, so step 2, isolate the ax squared and bx terms on one side of the equal sign. So I want the x squared and the 14x alone on one side. That means that I need to move this negative 51 to the other side, and I'm just going to do that by adding it. Because what's negative 51 plus 51? 0. And then 0 plus 51 is 51. So x squared plus 14x, and then technically this would be plus 0, but if I add 0 to this, does it change it? No, it doesn't. So I don't actually need it written in here. So now we're ready for step 3. You're going to divide b by 2 and square it. So remember, we're using b divided by 2, and we're squaring it. In this case, b is equal to 14. b is equal to 14. So we're going to take 14, divide it by 2, and we're going to square it. So we get 14 divided by 2 is 7, and 7 squared is 49. So now we're going to add what we found in step 3 to both sides of the equation. So we're going to take x squared plus 14x equals 51, and we're just going to add that 49 to both sides. What we do to one side of an equation, we have to do to the other. If I add 49 to one side, I also have to add it to the other side. So I'm going to go ahead and simplify that right side. What is 51 plus 49? I believe that's 100. I wish you guys were here to correct me when I make mistakes. I missed that. All right. So now we're going to rewrite, step 5 is to rewrite the standard form side as a perfect square. And all that really means is factor it. So x squared plus 14x plus 49, we're going to factor that thing. So x times x would give me that x squared. 7 times 7 would give me 49. And then positive 7x and positive 7x would give me 14x in the middle. Well, now I have x plus 7 times x plus 7. How can I rewrite something times itself? I can rewrite it as a perfect square. X plus 7 squared is equal to 100. Now we're ready for step 6. Now solve the equation algebraically. To do that, we need to square root both sides. So do you see how the x plus 7 is being squared here? To get the x out from being under the square, we need to do the opposite of squaring, which is square rooting. So the square root cancels the square. We're left with x plus 7 equals. Now, how many answers do we get when we square root something? We actually get 2. How do I show those 2 answers? I get positive or negative. And then what's the square root of 10? Sorry, what's the square root of 100? 10. All right, now we need to solve for x completely. So x plus 7. I need to subtract 7 from both sides. So x is equal to negative 7 plus or minus 10. Now, how many answers does this give me? This actually gives me 2 answers. I can split this into 2. I get x is equal to negative 7 plus 10, and x is equal to negative 7 minus 10. So x is equal to 3, and x is equal to negative 17. So then my answers are x equals 3 and negative 17. That means that if I graphed this parabola, if I graphed the equation, what was the original equation? If I graphed the equation y is equal to x squared plus 14x minus 51, if I graphed that equation, where did I get this equation from? It's just the original equation that we solved. Where would this equation hit the x-axis? Where would our x-intercepts be? Our x-intercepts would be at positive 3 and negative 17. So we would see a parabola that goes through those 2 points. And that's obviously a really, really rough sketch. Not a perfect graph here. For part B, why don't you go ahead and hit pause, try this equation out on your own, and then press play to check your work with mine. So the first thing you should have done is we need to make sure this equation is equal to 0. It's already equal to 0 for us. How nice. So we need to isolate the x squared plus 6x terms. To do that, we are going to subtract this positive 8 to both sides. So we'll have x squared plus 6x alone. 0 minus 8 is negative 8. From there, you take your b, which in our case is 6, and you divide it by 2, and then square it. So 6 divided by 2 is 3. 3 squared is 9. Then you need to take what you found in that step. So what we found was 9, and you need to add it to both sides. So we're going to add 9 to this side and this side. What you do to one side of an equation, you absolutely have to do to the other. Otherwise, it wouldn't be equal anymore. So then we are going to factor the left side here, and we're going to simplify the right side. Negative 8 plus 9 is simply 1. I know x times x is x squared, 3 times 3 is 9, and then positive 3 and positive 3 will give me that positive 6x in the middle. How can I rewrite x plus 3 times itself? X plus 3 squared. And the reason why we want to do that is because how can I easily cancel this square? I can go ahead and square root both sides. The square root cancels the square. We're left with x plus 3 is equal to, the square root of 1 is 1, but how many answers do we get when we square root both sides of an equation? We get 2, and we show that by writing plus or minus. So now we have x plus 3 is equal to plus or minus 1. Now to solve for x completely, we're just going to subtract this 3 to both sides. So x is equal to negative 3 plus or minus 1. I have 2 answers. X is equal to negative 3 plus 1, and x is equal to negative 3 minus 1. So x is equal to negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. So our solutions are x is equal to, x is equal to negative 2 and negative 4. All right, go ahead and press pause and give part C a shot on your own, and then press play when you're ready to check your work with mine. The first thing you should have done is make the equation equal to 0, so plug in 0 for y. So 0 equals x squared plus 14x minus 15. Then you want to isolate the x squared in the 14x term. So add 15 to both sides. 0 plus 15 is 15. Now x squared plus 14x are alone on the right side. Then we need to take b, divide it by 2, and square it. So we're going to take b, which is 14, divided by 2, and square. So 14 divided by 2 is 7. 7 squared is 49. Now we're going to add the 49 to both sides. So we're going to add 49 to both sides. $15 plus 49 is 64. And then we need to factor the right-hand side. So to factor this, I know that x times x is x squared. 7 times 7 is 49. And then I need positives, so when we add, we'll get a positive 14x in the middle. I'm going to rewrite the right side because x plus 7 times itself is really x plus 7 squared. Then how do we cancel the square on the right side? We square root both sides. So the square cancels the square root cancels the square. We're left with x plus 7 equals, and then the square root of 64 is 8, actually positive and negative 8. So the reason why we can call our x-intercepts roots is because you are literally square rooting both sides of the equation. What was the root of the equation? Then subtract 7 to both sides. So x is equal to negative 7 plus or minus 8. We're going to split that into 2. So x is equal to negative 7 plus 8. So x is equal to 1. X is equal to negative 7 minus 8. So x is equal to negative 15. So our answers are x equals negative 15 and 1. And there you have it. And this is our last day of solving by completing the square. Tomorrow we're going to move on to solving using the quadratic formula.